Hello everyone, we are Team 8 from ECE 3011 and this is our invention, the robot called Professor Time. So Professor Time is a robot that helps first and second graders learn how to tell time on an analog clock. The classic two-hand, the stuff that's going out of style. So how our box, it was inspired by, we were supposed to pick a standard in the Georgia Department of Education public standards. And we were supposed to solve that standard, the teaching of it, using a robot. This is my team and I'll let them introduce themselves.
My name is Joshua. I was in charge of the digital subsystem.
My name is Puneet. I was in charge of the mechanical box and the power subsystem.
Hello, I'm Lara. I worked on the mechanical design of the analog clock.
Welcome. This is a demo for the Professor Time robot. And the idea is that when I turn the switch on up here, you can snap across the microbit to activate the robot. And what will happen is the analog clock will display a time down here, and the student can input the time in the digital LCD to correctly correspond with the analog clock. And if it's correct, the microbit will play a little sound. So for instance, we can see the time says 11:30 as it's in 30-minute intervals. And once the music stops playing, we can input it at the top. So right now it displays the standard set time 12, but we know it's 11:30 based on the digital analog clock. And now the music is currently playing. After you get a correct answer, the robot will again produce a different time that you can input in. Now lastly, the robot has this really cool art feature on the side, which allows students to interactively, based on the time, put on what they'd be doing in the day. So at 11:30 at night, you'd be sleeping, but perchance if it was 12 p.m. in the day, you could say you were doing recess at school.
So I'll talk about the analog clock in the front now. And in this one, the biggest challenge was like in a normal clock, there's two hands that move in the fixed frequency in the same direction. But our STEM kit requires that these hands should be moving in different directions and different amount of range. So for that one, I designed a mechanical subsystem that allows this concentrical motion for both of the hands independently. So they have their individual motors, 260 degrees rotational capability for each hand that allows us to show time for the students to answer their questions at.
Next, we're going to talk about the digital subsystem. So the digital subsystem encompasses this PCB right here. Now, the purpose of this subsystem is to allow the users to use the digital clock. You can see that there's 8 buttons that control each digit of the time correctly. We can see it goes up and down as you saw in the demo. We also have the microbit here as well. And I think some of the challenges with this board was designing a PCB for the first time. A lot of the times we had trouble with getting the correct connections and figuring out the correct schematic. And a lot of the times we had to white wire a little bit just to fix up the PCB. But in the end, we were able to create this PCB to allow the users to use the digital clock.
We're here for the power subsystem. We have this little power PCB in the upper right-hand corner that provides 6 volts to the motors, 3.3 volts to the microbit, and 5 volts to the LCD right here. And the biggest challenge with this power PCB was providing enough voltage for all 3 systems. But also right here, we initially didn't have a toggle switch for the power PCB, but we implemented a unique solution to add this in. Talking about the mechanical box and how it was designed. So we originally CAD'd the design in 3D CAD and came up with this box shape just because it's easy to hold, and for first graders it's a larger item to play around with. And so we wanted to add this little cool sketch of Professor Time in the front just to give it a little personality. And then the biggest thing here was this art aspect on the side. And that was done using just wood and attaching some screws so that the piece can slide in and out and is easily accessible for students. And one of the toughest things for this box was just the acrylic on top and getting to fit with the wood components on the side. Just because this acrylic is slightly thicker than the wood, it was tougher to fit it in, but luckily we were able to figure that out and get it all working.
So all the software for this was done in Python, and it was using the Python editor that Microbit provides. Some really important things that we used is I had to create a library for running the servos and setting a time. So 2 libraries were needed in addition to that. One to write through the I2C to the digital display so we can change the time with the buttons. And also one to make sure the motor time is being set correctly and accurately every time we have a time that corresponds with the correct answer. All this was done in one big while loop with a bunch of set and non-set variables to go into different parts of the code, sort of like a state machine.